Hello everyone. Today we're going to do circle graphs, but we're going to do circle graphs over 2 days. We'll start by doing a quick review of percents because you need those for circle graphs. Then we'll do an introduction to circle graphs and read a circle graph. And then next lesson we'll actually make a circle graph. That can be a bit of a drag. Okay, so yeah, we're going to start with percents. I know you're familiar with percents, but sometimes people get confused about how to calculate percents, and it is important in this section. So, what's a percent? Do you know this? Percent, cent. Think of some other words that have cent in them, like the word cent, or the word century, or the word centimeter, or centipede. So, what do these words mean? Well, cent is 1/100th of a dollar, right? A century is 100 years. A centimeter, well, there's 100 centimeters in a meter. And a centipede, the idea is that it's this little bug that has 100 legs. Usually they don't actually have 100, but that's how it got its name. 100 has something to do with hundreds. Per 100, well, it's per 100 or out of 100. That's absolutely what this means. Percent is actually a ratio. How exciting! We've talked about ratios in this course. It's a ratio. Remember, it's a comparison of things. So what you're comparing in a percent are two numbers when the second term is 100. So it literally means out of 100. And I know you know this. It's represented with this symbol right here, right? All right, so let's just look at this fact that it's a ratio. If it's a ratio, one way I could represent it is as a fraction. So let's do that. Got to make a fraction here. And it says the second term is 100. So whenever you have a percent, you could actually write that percent over 100, right? So for example, if I said 40%, you got 40% on the test. Well, another way you could write that is that you got 40 out of 100. If I told you that 88% of students at King George love playing baseball, boy, is that ever not true, then you could say 88 out of 100 people like playing baseball at King George. What's the point of percents? Why do we do this? Because it's hard to compare if we don't have percents, right? If you wrote a test in math and you got 12 out of 17, yeah, it's pretty good. And then your friend wrote a math test in a different math class. They have Mr. Yee or something, and they got 42 out of 57. Mr. Yee gave us a really big test, 57 marks. And you want to know who did better. It's really hard to say who did better just by looking at that, isn't it? But if you change them both to percents, it's dead easy. I won't go in right now how to do it. I'll do it in a second. But 12 over 17 is 70.6%. And 42 out of 57 is 73.7%. Ooh, I'm sorry, your friend did better. Okay, so this is the point of percents. It's a standardized amount. It makes it very easy to compare. All right, so percent and 100. 100 is like the whole amount, right? That's what the whole amount is. And then the percent is the part of the whole that you got. And this is actually a proportion that I use to solve all percent problems. This exact proportion in this red box is what I use. You don't have to do it this way. There's lots of ways to solve percents, but what I find is people often get confused between the different parts. So then when they're trying to find, for example, what percent is 20 out of 40, they're asking me, do I multiply 28 and 40 and divide by 100? Or do I multiply 28 by 100 and divide by 40? And then same with this, what's 44% of 225? Oh, do I multiply 44 by 225 and divide by 100? Or divide 44 by 100 and multiply? Oh, I'm so confused, Mr. Wadge. So this will help you out right here. You can use it for all types of percent questions. It actually turns out there's 3 types of percent questions. One's calculating a percent, so that's when you don't know the percent, right? You're trying to find the percent. The second type is when you're finding a percent of a number, so you know the whole number and you're trying to find the part. You're trying to find the part. And there's another type, I guess I'll just write find the percent here. There's a third type of question is when you're trying to find the whole, but we don't really need to worry about those when we're doing circle graphs, so we'll just do these two, finding the percent and finding the part. Okay, let me show you how this works. if you want to know what percent is 28 out of 40, now you might be able to do that right now, and if so, go ahead, that's great. But if you don't, use my little proportion here and it'll work. So I'm going to set up the proportion. Okay, which of these four parts never changes? Which of these four numbers, if you want, or which of these four? The 100, it's always there. This 100 just sits there every time. So don't even think about it, put down 100. Okay, the next easiest thing to worry about is the percent. You know whether if you're actually given the percent in the question, because you'll have a number that says 28% or 62.3%. Do we have that? No. Here it says what percent. We don't know the percent. So maybe I'm going to put a letter here to indicate I don't know it. I'll put N, right? That's our unknown. Okay, then one of these numbers, the 28 and the 40, one must be the part and one must be the whole. What's the whole amount? If it's 28 out of 40, oh, the whole amount must be 40 and the part must be 28. That's only part of the 40. Great, now we have a proportion where we know three things and we're missing one. Oh my goodness. How do we solve it, people? Say it with me, please. Cross multiplying. Right? I told you at the start of the course this is like the most important skill in the course. We got to be able to do this. So remember, there's two diagonals. There's this one and there's this one. For the second one, this one here, we do not know both numbers. We don't know the n, so we can't multiply that. So let's get rid of that. So in order to get our n, what we're going to do is we're going to multiply 100 times 28, and then we're going to divide that by 40. So 100 times 28 is 2800, and we're dividing that by 40. 2800 divided by 40 is 70%. And we're done. Okay, let's do one more of those. What percent is 23.2 out of 55? Ooh, scary numbers because of decimal. It doesn't matter. It's just as easy. So, again, we're going to set up our proportion. What number can you put down right away without even thinking about it? 100. It's always there. Don't worry about it. Do we know the percent? Do we know the percent? No, it says what percent, so we don't know the percent. So put your M or N or X or Y, or whatever you want. What percent is 23.2 out of 55? Well, out of 55 sounds like the total, and 23.2 sounds like the part. And then you're ready to cross multiply again. You're going to multiply those and divide by 55. So you get M equals 100 times 23.2. Maybe I should put a times sign because that dot there, that decimal. And then we're going to divide by 55. Well, the top's easy. Multiplying by 100, you move it over two spots, so you're going to get 2,320 divided by 55. I'm going to calculator for this one. It ends up being 42 point, and a long decimal, I'll just do it to one decimal place, 42.2% is the answer. Okay, so that's one type of percent question when you're finding the percent. Now let's see how you do it when you find a part. So it says, what is 44% of 225? So again, you can start by setting up your proportion. What number can you write every single time? 100. It's always there, so we're going to put 100 down. Okay, now remember, the next easiest thing to find is the percent. Is there a number like 52% or 38%? Yeah. What is 44%? You know the percent. The percent is 44. So we're going to put 44 here. And we're left with one number, 225. Is that the whole amount, or is that just part of it? That's the whole amount. 225 is the whole amount. So remember, whole goes on the bottom here. So that's your 225. And what you don't know is the part. And so there's your, I'll put X this time up here. By the way, do you notice that for all the wholes, like this was a whole of 40, and there's the word of. This is the whole 55, there's the word of. This is the whole 225, there's the word of. It turns out not always, so this won't always be the case, but very, very often, if you see the word of, then the number is the whole. And if you see the word is, the number is the part. But that won't always work, okay? All right, let's solve this one down here. So we're ready to cross multiply. Which diagonal do we know both this time? Not this one. We do not know the x. It's this one this time. So in order to get the x, we're going to multiply 44 times 225, and then we're going to divide it by 100. Wow, 44 times 225. It's 9,900, and then we're going to divide it by 100. And if you divide that by 100, you get 99. What a nice answer. 99. Okay, let's do one more of those. What's 15.2% of 38? Don't freak out with the decimals. It's just as easy if you have a calculator. What number can you always put down right away without even thinking about it? 100. Do you know the percent to put up here? Is there a number like 38% or 17% or 15.2%? Yes, you do know the percent. Again, remember, what does 15.2% mean? It means 15.2 out of 100, right? That's why it looks like this, because percent means out of 100. Okay, of 38, 15.2% of 38. Well, I told you before, the little hint, of means whole, but you should also just be able to recognize that that is the whole there. And so I'll put y for the part. That's what we're trying to figure out. This is our diagonal right here. Y equals 15.2 times 38, and then divided by 100. 15.2 times 38 is 577.6. We're going to divide that by 100. Divide that by 100, you're going to end up with 5.776. Maybe I'll just round it to 5.8. There you go. Okay, so there's a very quick review of percentages or percents. Oh, by the way, another word for percentage, percent is percentage. Okay, let's talk about circle graphs. Now, I have a lot of things to write down here. I'm sorry. Another name for circle graph? Pie graph. So sometimes I'll probably say circle graph, sometimes I'll say pie graph. Same thing. What a circle graph is a visual representation, right? It's visual, it's easy to see, of how a whole is divided. So basically you're taking a whole amount and you're dividing it into pieces, right? The whole circle, the whole pie, that's the whole, and then you divided it into pieces. And each piece is a certain size depending on how much of the whole it is. Sectors of the circle, so each one of these different colors here is a sector of the circle, represent percent of the total, right? Again, bigger piece of the pie equals bigger percent. It's used to compare amounts. So it's very easy just by looking at this. If I said which one's the biggest, your eye just naturally goes boom, there's the biggest. It's very easy to compare things with this. And it represents discrete data. Uh-oh, it's the old discrete and continuous thing. Have you got it yet? Here's one last time, I'll go over it. Discrete data. Discrete data is data values that are distinct and can be counted. So remember, you don't measure these things, you just count them. If I was talking about the number of kids in each school, in each class at King George Secondary School, I would just count them, right? And I'd say workplace has 16 kids, and calculus has 30 kids, and math 8 has Mr. Wadge's Math 8 class, there's 27 kids, etc., etc. And then on our pie graph, workplace would be a small piece of the pie because there's only 16, and then this one would be bigger because there's 30, and etc., etc., right? Like that. By the way, what should all the percentages add up to? If I was to add up all the percents in a pie graph, what should they add up to? Well, it should add up to the whole amount, and the whole amount of something is what percent? 100. So you'd expect them to add up to 100. However, having said that, sometimes you'll add them all up and you'll get an answer like 99 at the smallest, 99, and at the highest you'd get 101. Why would that be? How could you get between 99 and 101? Depends with rounding, right? If you're rounding them all to whole numbers, it's possible that you've rounded down a bunch of times and so it only ends up at 99, or it's possible you round up a bunch of times and it ends up at 101. But if you went to like a couple decimal points, it'll always end up at 100%. Always, 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 unless you've done something incorrect. All right, let's read this one circle graph. So we're talking about favorite genre of films. I guess they asked some class or school or something, what's your favorite type of film? And here's where here were the choices, and here were the results right there. So the first question, what's the most popular genre of film? So, of course, there's two ways you can do it. You can look at all the numbers and see which one's biggest, or you just look at the pieces of the pie and see which one's biggest. And I see this one's the biggest right here. What's that? Well, if it's done this way, you don't have to have a legend, but they do have a legend or a key here. And you can see orange matches up with comedy. Of course, another way they sometimes do this is rather than having the key here, it'll say, like maybe in here, it'll say comedy. And it'll say action here. And then you wouldn't need the key because you'd have it written all here. I'm not going to write them all down, but you know what I mean. Okay, so there's different ways to make the pie graph. Sometimes they also have, for example, the next one's drama. Sometimes they also have it written out here. It would say 14% drama and horror 11%, like that, and foreign. I guess I am going to do them all after all. And SF for science fiction. Okay, so maybe a key, but not essential when you have a pie graph. Oh, we didn't write it down. The most popular was comedy. I can get that. It's very enjoyable to watch comedy movies. What's the least popular? Well, my eye goes immediately to these two. Which one's smaller? I got to look at the numbers. Oh, they're the same. The ones that are least popular are foreign films. Oh, what a shocker. Students don't like foreign films. And this is surprising a little bit. Science fiction. Boy, imagine if it was a foreign science fiction movie. No one would want to watch it. So those are the least popular genres. Okay, if 300 students took the survey, let's just assume it was 300 students. How many people preferred foreign movies? So foreign movies, we just talked about that, it's 8%. So what we want to know then, we've got 8% is what we want to know, and we have this number here. And we want to figure out how many people preferred foreign movies. Hey, it looks like we're going to be taking a percent here. Let's see if we can figure this out. Let's use our proportion method. So what can we always write down? The 100 can always go down. Do we have a percent? Yes, we do. We have an 8, so we can put 8 right here. This 300, that's the other number we know. Is that all the students that took the survey or only some of them? Is that the whole or the part? That's all the students. That's the whole right there. So 300 goes right here. This is what we're trying to find. I'll call it M, and we're ready to cross multiply. We are going to multiply this times this and divide by 100. So M equals 8 times 300 and then divide by 100. So that is 2400 divided by 100. If you divide that, you get that M is 24. So if 300 students took the survey, only 24 people liked foreign movies. All right, if 300 students took the survey, how many people like the two most popular genres? So what are the two most popular genres? It looks like they are comedy. We already said that was the most popular. And the next one is action movies with 18. Now, there's two ways you could do this. You could figure out what 27% is of 300 and figure out what 18% is of 300 and then add them together. But a faster way to do this would be to figure what total percentage is the 27 and the 18. Right? If 27% of people like comedies and 18% like action movies, what total percent is that? So what would you do with those percents? You would just add them together. So that's actually the first thing I'm going to do. I'm going to go 27 plus 18, and if I do that, I get 45%. So that's actually the percent I'm interested in. I'm interested in, if you want, this giant piece of the pie here, right? All that, and that amounts to 45%. How did I get that? I added together the 27 and the 18, and that gave me the 45. All right, so now we've got our 45%, and again, we have 300 students. We're just assuming there's 300 students, or I've been told that there's 300 students. So we're going to do the same thing. We're going to set up our proportion. What number can we write down every single time? You getting sick of it yet? Good. It's 100, isn't it? Do we know the percent? Yes, we do. The percent we're interested in is 45%. Is 300 all the students or only part of them? That's all the students. That's the whole. This goes here. Call this n or something and cross multiply. We need to multiply 45 times 300, and then we need to divide by 100. So we get 13,500, and then we're dividing that by 100. So if you divide that, you get 135. 135 of the students who took the survey liked either, comedy or action movies. Okay, so that is circle graphs or pie graphs. So today, what you'll notice is for today's work, you're going to be using this type of percent question when you're finding a percent or finding the part. And then next day when we actually make circle graphs, we'll be finding percents. All right, good luck everyone. See you next time.